So, that doesn't look right, but welcome to Fun Project Monday. Let me fix that first. That doesn't look good. Can I change that? Why can't I change that? Okay, I can't change that, I don't care. Welcome to Fun Project Monday. The live stream we design something, a product, LED controller, having some fun, no project managers, no customers, simply designing a little bit. And talking about what I design and what we design and what thoughts go behind anything. And why we do that and why we enjoy having simply some fun. I will drink coffee. Coffee is great. So, let's change back from this view. This doesn't look good. And take a look on what we're on. Last time we started working on the front panel, adding some switches and the right footprints. And that's the point where we left. The problem was that we were putting in these LEDs, that were those LEDs that we've got from light on, and we didn't find the right kind of footprint, which is very annoying. And we will change the footprint a little bit so we can have so we can be sure that while we put it into production or sort it ourselves, we will get the right kind of connection and the production will be reliable. That's important. So, so let's go to the pattern editor. One thing that I didn't do last time, I didn't have my libraries on. You can find them on GitHub and use those to power your own projects, I don't care. But I don't put my hand into the fire either, so MIT license. They're available on my GitHub page, no problem. So, we want to put in this footprint. It's I'm wondering, does it have a special name for light on? Does it? Doesn't look like it. No. No hint on the special name for that footprint, so we will simply name it. Can we take a template? There is no template that will make our life easier. So let's simply start. Let's go to the trace. So we'll simply put in this template. Let's see if I can make this fit the screen. That should be possible. So like that. No, that won't work. That will not work. So we will simply stay here. I will put the screen on like I need it. Okay, let's do this. Yeah, it's a little bit of a... Maybe I need to optimize my setup. But hey, who cares? So, we will put in this footprint. Oh, that are only the mechanical drawings. We want to have a footprint relatively easy. Nothing really world moving, but want to have that put in correctly, so we won't have problems later. So it will be name it LT for light on 28 for 20 2080 X for 20. That's nice. And we'll start with some pads. Okay, I think that was the surrounding. That was the part marking itself. I need to take an example again. Yes, I want to save it. For example, let's take the sensorion. Okay, that green line was the... Hello. The green line was the part marking, so we only want to have one line. And we want to have millimeters, because that's everything, because all markings are millimeters. And I like to use millimeters, because no freedom units with me. Good. So we have 280 millimeters. We need to find a pitch. So 280. That's good enough. Put that in the middle. Somehow like that. That will be this. No. Then we want to have the package outline. Package outline. Top assembly, and the top assembly will be representing the actual dimension of the part. So, and that will be completely in the middle, 0 and 0, with the dimensions of, what does the datasheet say, 420 by 320, no, 240, 320 times 240. Okay. So from that we can align. Oh, we can do it like this too. That's easier. We will start at 0, 0 will be our anchor point. Oh no, because it's no, we can't do this. We will simply line it like that. And do it like this. That's okay. And add the pads. We add the pads above here, 1 and 2. So the pads will have certain dimensions, and if we compare those, first of all we worked with these dimensions, and next we would work with pads themselves. So we will have an 280 times 110 millimeters pads with 2 pads with the dimensions of 280 times 110, and we'll put them apart 120 millimeters. So type dimension, and we want to have a surface pad, rectangle 1, width of 280 times 110, 0 corner radius, we don't need that, and we will change those, 110 times 280. So, okay. And we'll align them, so yeah, that's a bummer. Number position. Pad position is 0, 0. We will get, that's good. Now we need to do some basic math. That's of course every time something very nice on stream. So we have a complete length of 420. The pads themselves are 1/10 apart, so we will have a length of 2 millimeters in between. 2 millimeters times the middle times the average of a pad is 110 is 5.5, so 2.55. If the pad, yeah, 2.55, not 5.55. That doesn't look right. So first of all, minus 2.55. Of course, that's 0. Wait a minute. 420. Together the pads are 220. 1 millimeter. No, that looks correct. Let's put them 1 millimeter apart. Doing math on stream live is always something I really dislike. I'm gonna measure how far we are away. That are 1.5. Now we need to put them 1.5 apart. Yes, 0.5. Definitely not. Or is it? Oh yeah, it's better off. 1 point. We are almost the right size. So 2.55, 1.55, and minus 1.55. That's completely away. Nope. 1.55. Good. Now we should have our distance of 420, like the data sheet says. Let's check those. And that are... okay. We still need 1 millimeter. Let's, if we are on it, we can do it pretty accurate. And now we should have... oh no, I'm measuring the... yeah, but yeah, I'm measuring not the part itself, I'm measuring the grid. So let's try that again, and now we're at 420, perfect. So the cathode is the marked edge, and if the cathode is the marked edge, it's minus. I always get those mixed up. Number, that's K. Number 2, yes. But that's K. And that's A. So that's of course a D. Value doesn't have a real value, that pattern. Manufacture light on. And yeah, that's okay. Can add a 3D model, of course. I hope I installed those all models. Did I install? No, I didn't install them, of course. Maybe the pattern, the model generator can help us, but they're not installed either. Great. Okay, I think now we added a very basic model. Yep, I would need to install the models. And we'll add the model. That's great. So now we have, and we will rename those because it's not, that's not the right, no, that's right. We didn't name after the series, we named after the dimensions, so we can live with that. And save those. And now we can add in the pattern editor all the right pattern. Go to my parts, on light on. So this is the right way around. I said that the marked edge is the cathode. Yeah, that looks good. That looks good, yes. Okay. Save those. And as a value we will add the color. So we know, or what I like to do, instead of adding the color, I like to add a small letter inside the symbol itself, so you know what the color is. It's much more efficient, space-wise efficient, if you have a color inside of the LED. And now it's an easy thing to duplicate those and add the other colors, because we have different colors that we might use. And the easiest thing would be now adding all the other colors by simply duplicating the part. Can we do this? Yes, we can do this. Duplicate and duplicate. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8. And duplicate them again. Duplicate components. And now add all the other ones. Copy that. Oh no, they aren't. There are duplicates inside LCSC. Okay, that's interesting. LCSC lists a part as a duplicate, but with another, but with a discount. Now the interesting thing is, does the discount, make it bigger, have another part number? Of course, that would be. Where's the part number? Interesting. A discount part has a part number, so you rely on adding the right part. That is that's a bummer. That's really a bummer, because I think those discounted ones are limited too. That's yes, that's not very nice, and brings a lot of. I think that will be a real gutser if we need to work with that. So, but let's add the discount one. Did we add the additional fields? We added part number, and we added the part number of the discount one. Yes. So, yeah, I think, no, it's not a good idea. We can change those manually later, because if you now work with a discount part number and the part is not longer in discount, it will be quite an unfortunate thing to manage. So I will simply use the non-discount part numbers and use the other colors. So let's do this. So when we have an orange type LED, let me change one thing here. So let's add an orange colored LED, which is not in stock, but maybe we'll use it. AKT. That's also AKT. And we'll give it the part number. What kind of part number does it have? 66. 66. And of course now we're in a different. We'll change that to O for orange. Okay. And save that. Next we will have another discount part. We don't want to have that. When you have a new product, it's the SKT. SKT. SKT with the part number 44. Completely different. 284944. 284944. And that also will be in, let's check, that will be in yellow LED with a Y. Okay. And put it into a nice place. Y. Great. Next one. Next one will be red one. So we have an RKT, an RKT. But is it okay? Now I'm wondering. Because now the number scheme didn't change. So we have an COK KRKT. Yeah. With a part number of C120, 125, 125, 112. Okay, did we miss a letter currently? We'll check it later. Yeah, and that will be an R. Okay. Great. So, did we miss GKT? This is named. Okay, the orange one is named KAKT. Okay. Okay. And the yellow one is also named the yellow one. This one is also named KSKT. Okay. Great, we now done that. I almost think that the GT, let's check that. Do they have a problem in the naming? No, it's called TJKT. TJKT, so that's for some reason has a T. I almost think that there is some minuscule error different in those. We will need to check that. But now continue with the... We really should check that. Not that we have some difference here, because that would be something which is very unfortunate. Because they changed the naming scheme in between, and that's also a very unfortunate thing. Package seems the same. Peak forward current, okay, 30 milliampere. That's not. Oh, because it's only rated for 20. Maybe that's the difference. Do we have a number, another T, or another KGT? Okay, could be that the GK, that the G versions are only rated for 30. No, they are rated for 20. That's K. And the K1 is rated for 30, and the G1, that's the G1, right? Yeah, that's the T1, and the T1 is only rated for 20. That could be a difference, but nothing, fortunately nothing very significant or really important. So let's continue. Of yellow. Now we'll add B again. So there seems to be some sort of difference in manufacturing of the B version or with the green LED. So we have red. And we want blue. I'll do this one first. That's a yellow greenish one. KGKT. KGKT. Also KGKT. KGKT. And that's a C125. 111. Okay. Oh no, I changed the wrong one. Oh shit. So the red one is C125 112. Okay, that's still okay. Okay, that's all still okay. So now do the next one. LTSD C930 KGKT, and we will add some of those here. KGKT, and the KGKT is a 125 101, and it's a green, yellow greenish light emitting diode. Okay, so I put it GY, should be more green than yellow. Okay, and make this a bit smaller. No, that will stay where it was. And we'll make this simply smaller. Font settings. And that shall be free. Okay. Maybe 4. That can be 4, yeah. Yeah, 4 is okay. And put it one to the side. Better than nothing, really. Good, let's continue. Then we want to have And we have a blue one. Then we have everything we need. Oh, the blue one is also an T part, so it only work with 20 milliampere. And the JLC description is wrong. TBKT. Diode. Okay. C28495. That's not right. C284 945. Okay. That's okay. The two others we won't bother putting in. Yep. I will change that to blue. To a big B. Okay. So we've done that. They should all have the pattern right. Yep. Okay. And we'll delete those two. Good. Okay, then let's continue with the schematic. Now that we've done that, check something. Okay, good. Next we will connect those. Oh, another error that I noted. Of course, that need to be upside down, otherwise that MOSFET won't do anything. So we'll simply change the sides. Delete line. Delete line, and we will flip that. Horizontally. So yeah, that looks good. That looks good, and I forgot to add some resistors here. For normal operation, you wouldn't need a resistor for MOSFETs because MOSFETs don't care about the current that flows through them, they care about the voltage. But the problem is with having a high amount of... they have certain capacitance, and it's nicer for the ICs to have a resistor for them, because then the internal drive MOSFETs in the IC, in the controller, aren't that pushed. So we will most probably add certainly add resistors later. I'm still thinking about using resistor networks for having to handle less resistors, because they are physically bigger than normal resistors. And it's easier to work with them, it's nicer. You have less to do, less to worry about. And assembly is cheaper too. So I will add another switch. Why? First of all, we only thought about using 7 switches, but 7 is a prime, so we want there's no big difference in driving 7 switches and checking 7 switches instead of checking 8 switches, because you need to multiplex those. And so we don't have much difference, so we add another one. Why not? Maybe we'll use it. And we'll name those. I'm not quite sure what we wanted to name those. I will have one off switch. Then we'll have one channel select. Channel 1/blue. Channel 2/red. Channel 3/green. What we do is wanted to have one rotary encoder to work on the actual value, on the actual effect that you will use, or on the actual value, or the value of the effect of a color. So we'll have 3 switches to choose if you want to have channel 1, 2, or 3, or you want to change the color, And we have one button which will say channel color or effect select. I have another switch. Now we can, if we have an effect select, one of those can also do effect. So effect 1. Okay. Effect 2. And effect 3. That's cool. And the above and the under can be dark mode, so simply dark. Turn everything off, I don't care. Actually, that doesn't matter, because most probably it will be in soft on off, because there's no real need to have a complete on off. While doing nothing, the controller will not draw much power at all. So. And that's not really that is not really a critical part. So we will. Okay, yeah, what forward should we use? So we have an effect select. I will need to look on the documentation that was lost during saving to specify that. But yeah, that's no problem. So what we will do is we have one line which will connect to one set of buttons. We'll certainly need to make those a little bit. So, and we'll put them in order. We'll put them above. So that will be our first scanning line, and we have a second line which scans the second row of switches. Why not? At that point we can change the layout. I think at that point it's more interesting or more cleaner to work with signals. Or we put them, I think it's better if you put them, we don't think about putting them in the right order in the schematic. That's It will make the schematic less readable. And that's something which is unfortunate, and it is much more valuable if a schematic stays readable. So we do it like this. So S5, S6. S4. Put it down here. And we'll connect those together. I'll put it a bit so we have space for more text. And we'll put those together. Nah, it's not here. And that connection, that will be scanning line 1. Switch matrix. Okay. Switch matrix. Matrix. High side 1. And we'll have a switch matrix high side 2 with those. And the second line will connect with a signal, yes. So we have a in name. Or is it easier to... Let's first of all connect those. Yeah. Seven. 6 and 5. And we'll connect all of these. So and this net will be switch matrix high side 2. Can we get a net list? Great. And those we will connect together. I don't like that. Although, no, it's not too bad. Can certainly work with that, but I will put those a bit more down, so it's easier to see that those are in the same lines. So let's put some space for descriptions, and then we're set. So Good. I have no coffee anymore. Okay. So, and now we will yeah, add some net above here. Oh yeah, I wanted to check. I will check it another device of a project which I cannot show. How I did the naming. It is I always forget how to do the naming of the nets themselves. Yeah, where do I have this? I hate Windows 10, I really hate it. So let's check it out here. Because there's a nice way to name the nets in dip trace, and I want to use want to use that. So of course my laptop always switches to energy saving, which is annoying, really annoying. So I'm pretty sure I use that here. But I did not. I didn't use that in that project, okay. That is very fortunate. So I don't care so much. And this will definitely go to a connector. Because of the way we built the device, we'll have all the heavy, my goal is to have all the processing and everything on the bottom, so we'll use some kind of connector. Let's take a look on what's available. Some sort of really basic connector. These sub-SIM card pin headers. Pin headers, SIM card connectors, audio connectors, battery connectors. Because you want... There's no category for Molex ones? No, the terminal blocks aren't the right category at all. Nope. Here. It's not everything in the connection, so we want to have some wire to board, board to wire. That looks good. And we want to have some. Okay, let's check those. Yep, they look great. JST connectors, yes, that's the right ones. Can I filter for them? Deutsch connectors. What are those? I want to know what are those. There are also some kind of connectors, okay. So I don't care about them. Reset and take a look. JST. There are a lot of available. Question, are JST connectors available here? JST? C connectors, connectors. Connectors. Flat, flexible. Let's go through them. Edge cards. That's not correct. Memory, nope. Minor jacks. Rectangle board. You could use this one stecker. They are okay too. But our rectangle via two boards. Connectors, headers via two boards. Okay, here are Phoenix connectors. Let's take a look. That doesn't. Could be that one. Let's see what that is. Phoenix TB. Okay, the audio is not working smoothly. Why? I'm wondering if that audio is going through okay, but not simply not available here. I suppose it's only interfering with my headphones and the audio is coming go through. So that is very unfortunate. Okay, I'm overwhelmed with connectors currently. Let's take some wire to board connectors. Or CNC tech available at JLC PCB, at LCSC. If those are available, I will mostly use those as in first guess. CNC, no, they're not available. Okay. 1.25, but are Word connectors. They are expensive. RTE connectors, 3M. All 3M are available at LCSC. Okay. But not many too. And not the right kind of connectors. Nope. So... let's search. Maybe our search will help. Components group. And we want to know for simply JST. Is there something from JST available? Okay, at least something. Okay. Okay, let's take a look on what is available for JST. And if I get sound again. Now you don't have sound either. And let's see. Will we get sounds? Of course be great, but No, these aren't the right parts too. Oof. Okay, a rectangle board in. That will not be the right kinds. What are those? Nope, 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 nope. Do we have... Let's check. Do we have high rows connectors in here? Because I don't want to add new connectors. What do these all look like? Okay, I will not do this on stream, but we can add some LEDs to the front panel. That's okay too. So for the LEDs, there is okay. Can we update that? Do you have saved those? Save those, and now we have all of these here. So of course we want to have red, green, and blue LED for the channel selects. Red, green, and blue. Doesn't look like I will get music anymore. Red, green, and blue. Mm-hmm. So that's the nice part if you put the values or the color inside the LED itself, because then you can actually directly see what kind of LED you use, even without putting the part number inside the schematic. So, and that doesn't need to be that big. Yep, that's much more elegant. Yes. That's great. Okay. I don't know, I will see what I will do here. Okay, those we can directly connect to ground. Maybe we'll use a driver, just for not having to solder 20 SMD LEDs. And we want to have a red, green, blue indicator. Red indicator. We want to have a blue indicator. Sounds good. And we want to have that's a green indicator. Yep. That's a red indicator, and that will be no, that's bottom one is right. And that will be a blue indicator. Okay. So we know which kind of channel we've used. And then we have the channel indicator. The channel indicator, we can put them into a color which is not used normally. So we can have 3 yellow LEDs for different channels. You can even design those that we have 1 and 2 and 3 actually lighting up. That's great. I'll do this. in the later stages of a design. We have a channel 1 indicator. Channel 1 indicator. Yeah, this is like this. Okay, we have a channel 2 indicator. Okay. And we'll have a channel 3 indicator. Okay. Next we will add an indicator for an effect. Can actually copy that completely. So we'll think we'll do most things with yellow LEDs. So you can have a connection indicator, so you're connected to your device. I don't know, connection indicator. Let's do some guesses. We don't have to implement all of those. Connection indicator. We'll have oh, let's do it differently. Let's do an 3 indicator. So we can put in, let's put in a 2 indicator and a 1 indicator. We will have a channel indicator, so we know that we're using a channel. Let's put those inside that. We will have a channel indicator. Yes, that's correct. We'll have an effect indicator. That would be great. Okay. And we will add a channel indicator, an effect indicator, and we have a remote control indicator. Oh, that's great. I think that should be enough. That's more than enough. So all of these can be connected directly to ground. Let's do it like that. Like that. I still don't got music. That annoys me. Okay. Let's try that again. So, it still has some battery left, so it should work. Let's try that. Maybe the Bluetooth is bugging. Could be everything. Okay. Well, if I put this a bit down, that doesn't look good. And of course we need to add resistors for all of them. Like before, we won't choose resistors directly. We will put in first of all a dummy symbol, and after that I'll add all the interesting parts. So we add 4 pieces, put them in the right connection. So like this and like this. And now add lots of those. And lots of those. We don't want to delete that. That will be fun to assemble. That will be really. That is much fun to assemble, I tell you. And put those in and put those in. And remote. So this will go most probably into a shift register. So we put those on the bus. And after we have put those into an... So let's try one more time getting our sound, or getting my sound. No, it works. So that will be it will be remote. Let's call that remote indicator. Oh, I think we first will need to name that +0, and that is indicator bus. Okay. Still kind? It is. Okay. And that will be remote indicator. That will be effect indicator. So I do a lot of stuff to make it, because if you're working with 15 different LEDs and everything, I try to do a lot indicator. So let's start off this. That is the free indicator. I'll write them together like all of the other ones. So, free indicator. So. That's the 2 indicator. That's the 1 indicator. That's the red indicator. That's the blue indicator. Oh, that was a green indicator. Okay, let's change that first. And that's the blue indicator. And that's ground. want to have net ports and ground. We use ground like that. And for the last, put that to the side. We'll add our one chosen rotary encoder. So this Alps part. And was it this Alps part? Didn't we choose one with a long shaft? Didn't we? Let's check our history. So let's check our history to find. Okay. Check it like that. Switch accessories. So it will most probably be here, and I think we chose the last one because we need to go. Or was it enough? I don't know anymore. Ah, shit. let's check what we wrote down. Maybe there will be some sort of. Is it here? Or was it with EC11? Oh yeah, it was with EC11, I'm sure. Yep, that's right, EC11. Okay. Let's check if we EC11. No, that's not the right one. Okay, let's check if the EC11 is part. So here. If that is available in our components here. We want to search for Alps EC11. And yeah, simply search everywhere and give me an estimate. Because that would save us a lot of, again, a lot of hurdle to find that. Yeah. Oh yes. Okay, that's not the right one. Nope, we don't have them. Do we have Alps part? We have parts from Alps. No, we have part from Alps. Because if we already have Alps parts, we can maybe get away with changing one part, and that would be much more time efficient. Or maybe we already have a footprint which is very similar to what we need, and that is of course something which is very good to use, and we don't. So we are able to add those by ourselves. That's great. Let's do this for today and then stop. That would be a great stop. New library. We want to have Alps. And we maybe don't need a new pattern, but we need a new library here, and we want to have an Alps part. We want to have an EC11. So put in an EC11. EC11 L15 or 1525 E05. I want to add a unique identifier. modifier, and we will add JS. I will do that later. I don't. Let's check that directly. Yes. You want to save it here? Yes. Oops. And let's check our unique name. Was it? I would really like to have an option to transfer if that's easier. So, unique name. And we want to have part number. Unique name is the same as here. And the part number will be C28. This again, C28. No, C26. 87 298 298. Okay, and great. So let's check if we have some sort of template. I'm pretty sure that there will be another rotary switch. Nothing here. Let's check in the components. Yes, I want to save this. Components. Yes. Let's check for rotary switches. They are certainly available, and they use an already made resistors, switches, push button, joystick, rotary. Let's take a look if we have a kind of switch that could fit. Okay, let's look for an encoder. An encoder could be also. Let's check for an encoder. No, it's of course, yeah. Let's check. Okay, we don't have encoders in here. Conductors. Sensors, nope. And the encoders. Slide switches. No, that's definitely not the right thing to. Tactile, no, definitely not. We need to have encoders in here. We really need to have encoders in here. I won't believe that we don't have encoders. Definitely not connectors. Optimize the encoders. That are all not the right thing. Especially no, the footprint could be pretty similar, but definitely not the right thing. Okay, we don't have encoders inside. That is at least no encoders that I could find relatively fast. It's something I don't want to do. That's something I really don't want to do. But yeah, who cares? Do we have an... Does this one have a push button? I don't know. So let's take a look on the pin out. Oh, it also had a push button. Okay. So let's use. Then let's build an encoder. Why not? And use an encoder. So we start by taking a border. Something like that. And draw this. We'll duplicate that. And duplicate this. So thank you. And check that. So make this a bit smaller. Put this inside here and change it. So that's great for the encoder part, and let's do the same for the other part. Rotate, because on the other side we will need to add a switch, and the switch we will do very simply like that. So that's quite obvious a switch. On the encoder part, put that a little bit further up. First of all, we'll add a more coarse, not that coarse. Oh, come on. So a little bit. So like that. And add those. Those and those. And with a few oh, yeah. I don't like that. So put like that here. Okay. copy this. Make that one smaller, because it doesn't need to be that big. To show what it should do. Make those. So like that. Like so. And like so. Yeah, that's great. That's really great. And add on switch in the middle. Okay, that's a symbol I can definitely live with. Add 3 pins on the And change those. So one side encoder and the other side a switch. Good. Let's check if there's a naming scheme recommended by the manufacturer. If there is, I will of course use it. And we see we have A, B, C, D. It's called A, B, C, B, and D. I would like that. At least I will correlate the number with the letter. Name is B. Name is B number 2. It will be name C number 3. Then that will be D. That will be D number 4. We don't need, the names are not that important into this. And here it will be number 5 and called E. And that will be number 1. Name will be A number 1. Great. And we need this. And it will be Alps, and we will need rotary encoder. Uh-oh. Can't name it. We name it switch. S. Or X. And PCB's S is way more common. Value it has no value, no data sheet. Okay, I'm happy. Yes, I want to save that. We will add a pattern. For this pattern, of course, we will we'll do it. We'll take a lot of care to do it like the manufacturer recommends. So 5 pins. 1, 2, 3, 4, 5. We will change the pattern. The pattern, it will be a through hole. Let's see what the manufacturing says. It should be pins themselves should be 1 millimeter in diameter. Diameter 1. And the shape should be like to make them up round. So do we have some sort of recommendation for the size of? No, we have not. So we're simply do it 2 and 3. Let's see how it looks. Yeah, that looks good. Change those. Okay. And we will take a look on the direction. From the middle, 7 and 2.5, we'll add those numbers. Pad X will be 2.5 and 7. Okay. That will be... Oh, we need to check that we use the right numbers, of course. D and E. That is A. That is 2. That is... Pad 5. Yeah, that's 5. We'll use those. That will be 7 and 2.5. That is of course wrong. Now here. 7 and 2.5. And another one. 7 and minus 2.5. The other one, 7, distance of 7.5. It's of course very nice that you use, but of course 2.5 also. Pad 3 will be on the side, so it will be plus 2.5. Great. And let's go further. Pad X will be 0 and minus 7.5. Ah, trap. 7.5. 7.5. And minus 2.5. And minus 7.5. That's great. What are those holes? When we have two rectangular holes, okay. We should do them 5 and 2.6, so we'll do a hole of 2.6. Yes. Or can we make an... I wouldn't know how to do an rectangular hole, to be honest. Well, let's do it 2.6 in diameter, that should be good enough. So diameter will be 2.6. 2.6, let's do a keyboard of 4. And it needs to be placed 12.5 millimeters to the side. Or are those both? These are both. So 6.25 to the right. And that shall be, delete that one. That shall be 0. That shall be 6.25. Okay. And that shall be 0. Yes, that looks good. And we will add the white. Add some kind of we'll add some kind of placement. So we'll have I want to have this. Want to have this measuring. Oh. So we have a square. Of 13.1 times, so 11.7 times 11.7 for the first square. 11.7 and 11.7. And the anchor point is in the middle and it's at 0, 0. I can do it 13.1. So yeah, what will be top assembly? Let's do the top assembly stretching out to the sides. Let's make that one a little bit bigger. Just no, we keep that one at 11.7 0. Okay. I'll need a break in short time. So 13. Well, the square itself is 11.7 times 11.7. No, 11.7 times 12. So it's right. Oh my god. Times 12. That doesn't look right. And let's do a top outline. Yes, I want to display it. I have a top silk. Well, that is. Can put this like that, just to say that this is the assembly, this is the bigger part, and the top silk will be what is specified. Yes. No, wait, it was the other way around. Yep. I'll end that stream. I am not very concentrated anymore. Was like always fun. Doing a lot of pattern work and putting some switches on the schematic in 1.5 hours. Great. So I will save this and it will be done correctly off screen. Or the next time. Goodbye.